All right, here's our objectives for simple inequalities. We'll introduce that concept, present the properties of them. Get my pen out here, and then we'll solve them. So we've got the inequality. There's our less than. I always like to think of it as pointing, for our number line, it's pointing to the lesser numbers, right? Less than, and then you got less than or equal to. For example, negative 2 is less than 7. That's true. Negative 2 is less than or equal to 7. That's also true. Negative 2 is less than or equal to negative 2. That's also true because it's or equal to, because of that one underneath it, right? Or equal to. Is negative 2 less than negative 2, though? That's false, right? So, or equal to means it could be equal to as well, right? Then, of course, we got the greater than symbol and the greater than or equal to. We've got those properties of equality also hold for inequalities, right? So as long as you're multiplying by the one multiplication property we should mention, though, if you've got like a 3 is less than or equal to 5, right? If I multiply one side by a positive 2, this is still true. 6 is still less than or equal to 10, right? Now look, if I multiplied that by a negative, though, so that's that top one right there. But if I would have done it by a negative 2, is negative 6 less than or equal to negative 10? No, that's false. So if you're multiplying it by a negative, you got to make sure that you switch the sense of the inequality, right? If you multiply both sides by a negative, you got to switch the direction of the inequality. That's the only way to make that true. Same thing for if you're dividing both sides by a negative. If you have 3 fourths is less than or equal to 5. I'm sorry, hold on. 3 is less than or equal to 5. You divide both sides by 2, positive 2, it stays the same. But if you divide by a negative, you gotta, once again, you have to switch that sense of the inequality. You gotta switch that direction. Okay? So that's what you want to remember right there. If you multiply or divide by a negative number, you gotta switch the sense of the inequality. If you've forgotten that. Let's go ahead and do a few here. X plus 4 is greater than 1. Go ahead and subtract 4 from both sides. That's not an issue. X is greater than negative 3. X is greater than negative 3. Second one, x minus 6 is less than 9. Go ahead, add 6 to both sides. X is less than 15. Let's go ahead and graph these two just for fun here. X is greater than negative 3 means it's all values greater than negative 3, but I'm not including the negative 3. That's why it's open. So anything greater than negative 3 is a solution. Let's do this. X is less than 15. Less than 15, right? Less than 15. So the next one, we got x over 2 is greater than 9. So I'm going to go ahead and get rid of, I'm dividing by 2 right now, so I'm going to go ahead and multiply by 2. Well, that's a positive 2, so the sense of the inequality stays the same. It's still greater than. X is greater than 18. Greater than 18. So anything above 18 is true, right? Fourth one. Here's number 1, 2, 3. Now let's do number 4 here. Negative 4x greater than 28. Well, this time I'm dividing by a negative. So since I'm dividing by a negative, I better switch that sense. So x is less than negative 7. Less than negative 7. So open hole meaning I'm less than. I'm not including negative 7. Right? All right, here's the fifth one. We're going we're going to isolate the x. So let's get rid of the 6 first. So subtract 6 both sides. Now I'm dividing by a -2. So again, if I multiply or divide both sides by negative, don't forget you got to switch that sense. Switch the direction of that inequality. So x is greater than -7. I'm greater than -7. Number 6. 3 minus x less than 1. Get rid of the 3. Negative x less than -2. And then I got to get rid of that -1. Again, that's divided by negative, so I got to switch that again. X is greater than 2. Greater than 2. Here's the seventh one. I'm going to go ahead and distribute that. So 6 times x, 6 times -5 minus 30. Make sure you get all your x's on the same side, on the left-hand side for inequalities. Get rid of the 30. Divide by 5. Now I'm divided by a positive 5, so I still keep that the same direction. Greater than or equal to 8. And then this time, notice it's a greater than or equal to, so I include the 8, so filled in. 8 and anything above is a solution to this inequality. Let's do number 8 down below. Let's distribute that. 3 minus 6x greater than or equal to 1 minus 4x. Get all your x's on the left-hand side. Get all your numbers on the other. I'm going to subtract 3 from both sides. So I got -2x greater than or equal to -2. I'm going to divide both sides by -2. That's a negative number, so I got to switch that. Less than or equal to 1. Less than or equal to 1. So less than 2. This is less than 2. On the second one, if you notice the -4x is greater than 28, I do get this a lot where students will sometimes try to add 4. Well, what happens if you're trying to add 4 is now you have this. Well, that's wrong, and this is totally different, right? So, well, I mean, you'd have to actually undo that again. So what you want to think about on this one is if the -4 is being multiplied right now, it's being multiplied by x, you got to do the opposite of multiplication. So you got to divide. If I divide both sides by a negative, now you got to remember, hey, I got to switch that sense of the inequality. So on less than, -7, less than -7. Let's do this third one. 2x minus 5 is greater than x. I got to get all my x's on the left-hand side. So now I'm actually left with 0 over here. But then I'll add 5 to both sides. So x is greater than 5. I'm greater than 5 on that. Okay. Let's get a little room for these last two. Go ahead and distribute these. Get all your x's on the left-hand side. Go ahead and get your numbers on the other. And now we're dividing by a negative here. So you got to switch that. Greater than -6. And last one, number 5, 4x minus 7 greater than or equal to 2x plus 9. Get your x's on that left side. Add 7. And divide by 2. Now that's a positive 2. So the sense of the inequality stays the same. So here's 0, here's 8. I'm greater than or equal to 8. So I'm including 8 in my solution there. All right, last one. We got an application. A car rents for $30 per day plus 23 cents. Okay, so it's a guaranteed 30 bucks plus 23 cents per mile. We'll call X number of miles. Okay, that's how much it costs you to rent a car, right? Like for example, if you went 0 miles, it would be 0.23 times 0, but it's still 30 bucks fee. If you went 1 mile, now it's 23 cents times 1 plus 30. In other words, $30.23. If you went 2 miles, 23 cents per mile. So 46 cents plus the $30 fee and so on, right? Now, they're wanting us to set this up as an inequality because they say, but you're on a daily budget, 76 bucks. So this total cost has to be less than 76 or equal to. I could be right on the dot, right? And now let's solve it. So how many miles could we go to stay within our budget of $76? Well, we'll subtract 30 from both sides. So I'll have 0.23x less than or equal to 46. And then I'm going to go ahead and divide by 0.23. And that's a positive, so that'll be less than or equal to. Then I punch in 46. Oops. Divided by 0.23 at 200. So I can go 200 or less miles to stay within my budget. All right. All right. Well, thanks for watching.